Hello everyone, welcome to another interesting episode in the Art of Engineering Efficiency. If you're a developer and working in a team developing a feature dependent on backend APIs, you might have faced few situations where you found contract discrepancies which is shared before development and post completion of the development identified during the testing phase. These things would happen pretty much common because the contracts which are shared by the backend systems would be updated in some kind of documents in a Confluence or shared over the email, and the time when frontend takes the reference to proceed with their development, if there is any data mismatch when we do the development, instead of string, what if we keep it as an integer, or instead of integer something like a float or something else. So these things, tiny mismatches may not be caught during the development phase, and as a developers, once build the request and response models, we go ahead by configuring our local mock systems and we proceed with the testing. These situations occur most of the time when front-end and back-end teams are working in parallel to develop their features. So that's where front-end developers mostly rely on mock systems to configure the responses for various endpoints to test the user journeys. So that's where the smartmock plays key role as a mocking system, as a developers or a backend team can configure a request structure for any specific endpoint, wherein when the front-end team access this endpoint through the mock system, it validates the request structure and the data types which are received from the front-end teams. If there is any tiny mismatch, smartmock identifies and warns whoever is consuming this mock API. So that's how smartmock API helps development teams to sync their request structures for various endpoints in sync with the API contracts which are deployed by the backend teams. Along with that, it also helps to configure various user journeys. So that's how smartmocks helps the development teams to boost their productivity and focus what is really needed as part of their development. Let's see one case study where the backend team shares the contract specification to the front-end team and they configure the smartmock system with the API specifications, and they configure various test scenarios in the smartmock systems to test further user journeys of the development. But there is a small change, like a new field introduced as part of the request and which plays as a key validation rule in the backend systems. Post the change, all of a sudden the applications which are delivered by the front-end teams are start breaking when they try to access this API which was previously developed and deployed to the testing teams. The test execution is completely blocked and the front-end team is completely not aware why this issue is coming now and why it's not there before. Post checking the logs, checking with the backend teams, then they identified that there is a new field is introduced as part of this existing API which plays the key validation to return the response for any request. So this is the situation where even we have a proper mocking system in place which validates the request and respond to the callers. Something is lacking here, that is, if there is any small change in the contract specification and if it is not updated in the mock system, whoever is consuming the APIs through the mock system may not be aware of the real change which is happening in the backend API, causing many issues pointing to the development team's productive effort. Now we have a solution to address this gap and keep things in sync always between the backend API specifications and in our smartmock system. So what does the latest smartmock does to address this gap? The latest smartmock brings OpenAPI contract specifications in sync with the mock system's API configurations. So let's see what are the key features of smartmock 2.0. As soon as any change to the backend API specification files like OpenAPI files YAML is committed to the master branch of the source code repository, immediately the same changes, whatever the request structure or any contract specific changes or part of the source code will be reflected in the mock system. That is the key feature of latest smartmock. So let's see latest smartmock in action with a simple demo and various use cases. Latest smartmock is already updated in GitHub to the previous version. We can find the detailed setup guidelines and use cases mentioned in the README file. Let's start how to set up smartmock 2.0. As a first step, make sure the system whichever we are running the smartmock server installed with YQ. Brew install YQ is a command used on macOS or Linux systems that have Homebrew installed already. It installs YQ, a powerful command line tool for processing structured data formats like YAML. Because I have been testing smartmock during the development, my system is already installed with YQ, so I am not demonstrating the installation of YQ in this demo video. You can try it either in your local machines or in your Jenkins machine. Next, let's clone the repository of smartmock into our machine and change the directory to smartmock. For me, I already have smartmock set up in my machine, so this is my repository with the scripts and a smartmock package and a readme file. Now let's run smartmock server. Smartmock is up and running. Let's go back to our folder now. I have a test repository created to test smartmock 2.0, which is test YAML, where test YAML repo acts as a source code of backend, where I will be placing YAML files to demonstrate the smartmock 2.0 features. Now let's copy scripts folder from smartmock repository and place it in test YAML. I have a set of YAML files, catalog.yaml and user.yaml to demonstrate. So I'll be using catalog.yaml file as a first step in demonstration, which are used in smartmock 1.0 demonstration. So if you need detailed usage of smartmock, you can either go through the readme file smartmock 1.0 release notes, or you can visit the podcast of smartmock 1.0. Let's copy this catalog.yaml file and place it in test YAML repository. Now our test source code repository directory is ready. Now we'll just have a look at the structure of catalog.yaml file. So this YAML file holds one endpoint, fetch catalog, with request body and a schema reference, and responses supported are 200 with the schema reference. So the default values are example values. If the example values are not mentioned in the YAML file, default values based on data type names will be configured in the smartmock systems if example values are not present in the YAML file. Now let's move to the interesting part where we configure the smartmock scripts in the Jenkins system. In my machine, I already set up Jenkins with the deploy mocks test.yaml job, where it points to the test.yaml repository and featured/test.yaml branch, where I will be pushing all the YAML files and the script changes into this branch for the smartmock 2.0 demonstration. The purpose of this job is to fetch the given branch from the repository once the branch is successfully cloned in the Jenkins system. Post that, it will start executing this Jenkins deploy mock script, which will identify either latest YAML file changes or all YAML files which are present in this repository, process them and configure the mock APIs in the smartmock system. So the extension key character Y represents which will push all the YAML files present in the repository. If the script is executed without Y character, the script will identify only the latest YAML files in the last commit and configure them in the smartmock system. This is a key change that to be noted by the developers or whoever is executing this script. As we haven't configured any mock in smartmock system, we will run frontend application to fetch a product catalog pointing to the smartmock system with the fetch catalog API. App received an error. The data couldn't be read because it is missing. The error is because there is no mock configured in the smartmock system yet. Let's push the code in the test YAML repository and trigger the build in Jenkins. In the logs we can clearly see all YAML files in repo. Because this is the first commit in the repository, we execute the script with an extension of y character so that it will push all YAML files in the repository. So here we can clearly see it identified catalog.yaml file and it is configuring the same in smartmock. Once the configuration is successful, we can see what are the endpoints and request structure and response structure configured in the smartmock along with the status, whether it is a new endpoint or it is something replaced to the existing endpoint can be identified in the status parameter. At the same time, we can also cross-check this API underscore contracts file which is located in smartmock directory. Now we have the mock configured through smartmock system. Let's refresh the front-end screen. The refresh call fetched the data from smartmock system. The default mock is configured for the given endpoint from the YAML files in the smartmock system. As soon as the code is pushed and a Jenkins job is triggered. Now deploy few test scenarios for the same endpoint, like the same way we did in the smartmock 1.0 demonstration. Once the test scenario is configured, we can cross-check the same in API scenarios file which is located in the smartmock directory. Now let's refresh the front-end screen again to see the test scenario configured for the first page to fetch the catalog. The integration worked very smooth in such a way that without interrupting the front-end application, the data is deployed in the mock system instantly without any delay. Now we have covered the key features of smartmock 2.0, identify the endpoints, request and response structures through the OpenAPI files such as YAML from the source code, and once the source code is pushed to the repository, a Jenkins job is immediately triggered and updates the mock system with the latest API configurations. Further, which can be consumed by frontend, backend or even QA teams to configure the mock data to test their user journeys or execute various test cases. Now let's assume that once the initial phase of the backend deployment is done, post that if there are any changes coming into the backend systems. For example, in catalog.yaml file, the current page property is expected as string initially. Due to some host requirements, the data type needs to be changed to integer. Along with request, there is a small change in a catalog response as well, where each product ID, which is currently an integer data type, is changed to a string data type. So now let's see the usual process. As soon as the YAML file is changed in the source code, once the changes are merged into the respective repository, a Jenkins build will be triggered in the given branch. And let's change the script by removing the y character in the deploy mock, because now we are updating the YAML file, so y character is not required in the script anymore. It will take the latest changes alone instead of reconfiguring all the YAML files in the repository. Let's trigger the build now. Ideally, this should be auto-triggered as soon as the PRs are merged, but because I configured the Jenkins in my local machine, I don't have access to any server. That's why I'm manually triggering the builds. Let's check the console logs. The build is successful. Now let's go back to the front-end application and I'm refreshing the screen now. We got an error from host saying that The current page object in the request is expected as integer but received as string. If we compare it with the YAML file, which are updated recently, the same thing is processed by smartmock and responded with the latest validations. Let's correct the current page data type in the front-end application and retrigger the build. Here we got another error saying that string value id integer value is nil because decoding integer but found a string instead. In the recent update to the catalog.yaml file, the id data type is changed from integer to string, and same thing needs to be changed in the front-end application. Let's correct id data type from integer to string and rebuild the application. Smartmock responded with the default mock, unlike previously where we configured a product list for a test scenario. Let's reconfigure the scenario deploying the same test scenario which we executed earlier. Smartmock responded with an error clearly saying that the current page is expected as integer but received as string in the request. Let's change the current page data type in the request and deploy the scenario. This time Smartmock responded with another error saying that the product list ID is expected as string but received as integer. Let's update the ID data type in the response of this product catalog and deploy the scenario. Smartmock again responded with a different kind of error. This time it says data type discrepancy in the object, where in the response of product list ID found with two different data types, string and integer. So let's look at what are the different products configured in this response. As this product catalog contains 10 products in this scenario, where previously we updated only the first product to the string data type, but rest of the products are left with the integer data types for the ID value. That's why Smartmock identify that there is a data discrepancy in the response configuration and responded with an error saying that the data types to be aligned as per the API configuration and deploy the scenario. Now the response and request both are matching with the configured API for the fetch catalog. The given scenario is successfully configured for fetch catalog endpoint. Let's go back to the front-end application. Refresh the screen. Product catalog list which is configured for the first page in the smartmock system. So far we have covered what are the key validations that smartmock do, early findings of the API integration testing, if there is any mismatch in the request data types or structure, or if there is any response structure as well, we can easily catch exact errors where the fix is needed. Now let's see an additional use case where we have another YAML file in the source code repository and see how smartmock system responds to it. Upon pushing, the build is triggered and the configuration of user.yaml is successful in smartmock system. Let's validate the contracts which are configured in the smartmock through Postman. Smartmock successfully configured the new endpoint user/onboard from the user.yaml file. Let's go through user.yaml file once to validate the request and response structure. So the smartmock identify the endpoints in user.yaml and read the request and response structures using the schema references and deployed in the smartmock system. Now let's try to access user/onboard through service API by giving a request, and let's see how smartmock responds. Smartmock responded with default values which are present in the YAML file. Let's see another use case by changing the script with a y parameter and see whether it is deploying all the YAML files in one shot or not. In the console log, we can clearly see the smartmock script identified there are two YAML files in the repository, and it configured each YAML file one after the other. In the status message, we can clearly see what are the endpoint, request structure and respective response structure as well in the console logs. Now we have covered most of the features which are available in latest smartmock. Let's see the last item where we can trigger the script from our local machine itself even before committing the code. Let's see how we do it. Let's open the terminal with the repo directory test.yaml. Use the same command whatever we used to configure in the Jenkins job to commit all the YAML files in one shot. So I'm executing the same in my local machine in the terminal to commit all the YAML files in my local repository, and here it identified all the YAML files and deployed one after the other from my local machine to the smartmock. Let's also try the second command just to deploy the latest YAML changes in the recent commit. It updated the user.yaml in the latest commit and deployed the same in the smartmock system. So that's all we have as part of this demonstration. I hope the demo is pretty much clear and you guys understood it very well. Smartmock is not just a tool, it's a gatekeeper that keeps both backend team, frontend team and even QA team in sync as part of their testing process. It makes sure the API structure, either request or response, are always in sync with the source of truth, which are OpenAPI files in our source code in the smartmock system, which helps to reduce and catch the errors in advance during the development and integration phase itself. If you have ever been stuck with any bad mocking system, smartmock is made for you. Smartmock is available in GitHub. Do give a try and share your feedback in the comment section of this video. These are the major updates and enhancements I have for latest smartmock in this episode. In coming episode, we will go through another interesting topic in software engineering process. Till then, stay tuned and thank you for watching.